In the memory system module of CO, we are now discussing about the different components of the memory system and how can we have a fast memory system with them. One way is to make use of the cache memory. We have discussed the various cache mapping techniques, cache coherence problem, its solutions, and also multi-level caches. Also, we have seen how to make use of this multi-level caches together with the other components such as primary memory and the secondary memory to design a proper memory hierarchy organization for a fast memory system. The next topic that we are going to discuss is memory interleaving, which is actually a method which is used to improve the access time of main memory. And along with a fast memory, we need a large memory too. The methods adopted for this is the use of secondary memory together with the virtual memory concept, which is discussed in the operating system memory management module. Now moving to memory interleaving. Memory interleaving is actually a method which is used to improve the access time for main memory. Before discussing memory interleaving, we shall have a brief overview of the internal organization of main memory. As we know, the main memory is implemented using dynamic RAM chip. Consider how the DRAM chips are organized for main memory. On the motherboard for main memory, there are dimm sockets, each socket holding a dimm dual in-memory module. Each dimm holds the DRAM chips on its either side. Suppose for this dimm there are 4 DRAM chips on one side. Then there will be 4 DRAM chips on the other side. Thus total for each dimm here there are 8 DRAM chips. And the set of all DRAM chips which participate in one particular data transfer request is together referred to as a rank. That is, suppose our data bus is 32 bits wide. That is, each data transfer request transfers 32 bits such that 8 bits are transferred from one particular DRAM chip. Hence, for each data transfer request, 4 DRAM chips should be involved. Such set of DRAM chips which are involved for one data transfer request is together referred to as a rank. Now, instead of a single chip, the involvement of multiple chips for one particular data transfer request brings a kind of parallelism within the request, and hence this will improve the data transfer bandwidth for one request. But for multiple requests or for a sequence of requests to achieve this data transfer rate, to improve the data transfer rate, we should bring parallelism between the data requests. For that, each DRAM chip is further divided into banks. Here, each DRAM chip is divided into 2 banks. Now we can see for each data transfer, actually one bank from each chip of this particular rank is involved. Now this set of banks which are involved in one particular data transfer will be together acting as a functionally independent memory module. Let this set of 4 DRAM chips be rank 0. Now this is rank 1, rank 2 and rank 3. Similarly, this set of banks, let this set of 4 banks be bank 0. Let this be bank 1, bank 2, bank 3, 4, 5, 6 and 7. Now each bank 0, bank 1, bank 2 and so on, each one will be acting as a functionally independent memory module. It means within that memory module, if there is one request, it can handle only one request at a time. If there is another request for that particular rank, then it should wait till the previous request is completed. But between the memory modules, it can achieve parallelism. While one data request service is going on for bank 0, if there is another data request for bank 1, then parallel execution is possible. Thus, division of DRAM chips into banks will help to simultaneously handle the data requests or parallelly handle the data requests. If we are dividing into more number of banks, say 4 number of banks, then the level of parallelism can be further improved. So in short, we can say our main memory system is organized into different memory modules to achieve parallelism between the data requests. Within one memory module, it can handle only one data request, and between the memory modules, it can achieve parallelism. But with this kind of organization, to achieve parallelism, we should make use of proper memory interleaving, which we will discuss in the next video.